Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data and make predictions or decisions. Instead of explicitly programming every rule, machine learning algorithms learn relationships from examples provided during training. A trained machine learning model can apply what it has learned to new and previously unseen data. Machine learning is widely used in forecasting, classification, recommendation, fraud detection, and many other AI applications. Traditional programming requires developers to define rules for every possible situation, which can become difficult for complex problems. Machine learning allows systems to identify patterns from large datasets without requiring every relationship to be manually defined. ML models can improve their predictions when they are trained with relevant and representative data. Machine learning is especially useful when the rules are difficult to describe, but examples of the desired behavior available. A machine learning workflow begins by defining the business problem and identifying the data required to solve it. Data is collected, cleaned, transformed, and prepared before being provided to a machine learning algorithm. The model is trained using historical examples and then evaluated using data that was not used during training. After successful evaluation, the model can be deployed to make predictions on new data and monitored over time. Features are the input variables that provide information to a machine learning model. A label is the known target or outcome that the model attempts to predict in supervised learning. For example, house size, location, and number of rooms can be features, while house price can be the label. Selecting meaningful features and defining the correct label helps the model learn useful relationships from the training data. Supervised learning uses historical data where the input features and expected target values are already known. The model learns the relationship between the features and the target so it can make predictions for new observations. Classification predicts categories such as fraud or not fraud, while regression predicts numerical values such as sales or price. Supervised learning is commonly used for customer churn, risk prediction, demand forecasting, fraud detection, and classification problems. Unsupervised learning works with data where there is no predefined target or label. The algorithm attempts to discover hidden patterns, structures, or relationships within the available data. Clustering is a common technique that groups similar data points together based on their characteristics. Unsupervised learning can be used for customer segmentation, pattern discovery, anomaly exploration, and exploratory data analysis. Machine learning data is commonly divided into training and testing sets to evaluate how well a model generalizes to unseen information. Training data is used by the algorithm to learn patterns and model parameters. Testing data is kept separate and used to evaluate the final model after training. Separating training and testing data helps identify whether a model performs well beyond the examples it has already seen. Model evaluation measures how accurately and reliably a machine learning model performs on data that represents its intended use. Classification models can be evaluated using metrics such as accuracy, precision, recall, and F1 score. Regression models can be evaluated using metrics such as mean absolute error and root mean squared error. The appropriate evaluation metric depends on the business problem and the type of prediction being made. Overfitting occurs when a model learns the training data too closely and performs poorly on new unseen data. Underfitting occurs when a model is too simple to capture important patterns in the data. The goal is to create a model that learns meaningful relationships while generalizing well to new observations. Techniques such as appropriate model selection, validation, regularization, and sufficient training data can help improve generalization. Azure Machine Learning is a cloud service that helps organizations build, train, deploy, and manage machine learning models. It provides capabilities for data preparation, model training, experiment tracking, deployment, monitoring, and lifecycle management. Azure Machine Learning supports different development approaches, including code-based workflows and automated machine learning capabilities. For AI 900, it is important to understand when Azure Machine Learning is appropriate for building. Machine learning enables computers to learn patterns from data and use those patterns to make predictions or decisions. Features provide the inputs, while labels represent known target values in supervised learning. Supervised learning predicts known outcomes, while unsupervised learning discovers patterns without predefined labels. Understanding the machine learning workflow, model evaluation, overfitting, and Azure Machine Learning provides a strong foundation for AI 900. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoom Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.